Hello and welcome. Today we're diving deep into the heart of countless machines that power our world, the internal combustion engine. From the cars we drive to the motorcycles we ride, and even the lawnmowers that keep our gardens neat, these incredible devices convert fuel into motion. While they all serve a similar purpose, there are two fundamental types you'll encounter: the four-stroke engine and the two-stroke engine. Each has its unique design, advantages, and applications. Join us as we demystify how these fascinating powerhouses work, stroke by stroke. The four-stroke engine, anatomy and principles. Let's begin with the four-stroke engine, which is the most common type found in modern cars and many other vehicles. As its name suggests, it completes one power cycle in four distinct movements, or strokes, of its piston. Imagine a cylinder with a piston inside connected to a crankshaft. At the top of the cylinder, you'll find valves, an intake valve and an exhaust valve, and a spark plug. The first stroke is the intake stroke. The piston moves downwards, creating a vacuum in the cylinder. Simultaneously, the intake valve opens, allowing a precisely measured mixture of air and fuel to be drawn into the cylinder from the carburetor or fuel injector. The engine is essentially taking a breath. Next, we have the compression stroke. Both the intake and exhaust valves close tightly, sealing the cylinder. The piston then moves upwards, forcefully compressing the air-fuel mixture into a much smaller volume. This compression significantly increases the temperature and pressure of the mixture, making it highly combustible and ready for ignition. Following this is the crucial power or combustion stroke. As the piston reaches the top of its compression stroke, the spark plug ignites the highly compressed air-fuel mixture. The resulting explosion creates a massive force that rapidly expands the gases, pushing the piston forcefully downwards. This downward motion is where the engine generates its power, turning the crankshaft and ultimately driving the vehicle or machinery. Finally, we have the exhaust stroke. The exhaust valve opens and the piston moves upwards once again. This time, its movement pushes the burnt exhaust gases, the remnants of the combustion, out of the cylinder and into the exhaust system, clearing the way for a fresh cycle to begin. So to summarize, the four-stroke engine completes one power cycle, intake, compression, power, and exhaust, over two full rotations of the crankshaft. This design allows for efficient combustion and relatively smooth power delivery, making it ideal for applications requiring durability and fuel economy. The two-stroke engine, anatomy and principles. Now let's shift our focus to the two-stroke engine, a marvel of simplicity and raw power, often found in smaller, lighter applications like chainsaws, dirt bikes, and some marine outboard motors. Unlike its four-stroke counterpart, the two-stroke engine completes a full power cycle in just two movements of the piston or one rotation of the crankshaft. This means a power stroke occurs with every revolution, making them very powerful for their size. The key difference lies in its design. Two-stroke engines typically lack the complex valve train of a four-stroke. Instead, they use ports in the cylinder walls, which the piston uncovers and covers as it moves. Also, the crankcase isn't just for lubrication, it's an active part of the fuel-air intake process. Let's break down its two strokes. The first stroke is the upstroke, which combines both compression and intake functions. As the piston moves upwards, it compresses the air-fuel mixture that is already in the combustion chamber above it, just like in a four-stroke. But simultaneously, its upward movement creates a vacuum in the sealed crankcase below. This vacuum draws in a fresh mixture of fuel, air, and crucially, oil, as two-stroke engines mix oil directly with the fuel for lubrication. The second stroke is the downstroke, which combines power and exhaust functions. As the piston reaches the top of its travel, the spark plug fires, igniting the compressed mixture. The resulting expansion of gases forces the piston powerfully downwards. This is the power stroke. As the piston continues its downward journey, it first uncovers the exhaust port, allowing the burnt gases to escape. Almost immediately after, it uncovers the transfer port. The fresh, pre-compressed fuel oil mixture from the crankcase then rushes through the transfer port into the combustion chamber, helping to push out any remaining exhaust gases in a process called scavenging. This fresh charge is now ready for the next upstroke. This ingenious design means that a two-stroke engine gets a power stroke every revolution of the crankshaft, twice as often as a four-stroke. This gives them excellent power-to-weight ratios and quick acceleration, perfect for tools and vehicles where lightweight and immediate power are priorities. Key differences and comparison. Now that we understand how each engine works, let's put them side by side and highlight their key differences, which often dictate their specific applications. Power delivery. Four-stroke engines provide one power stroke for every 2 revolutions of the crankshaft. This results in smoother, more consistent power output, making them ideal for vehicles like cars and trucks, where a steady, refined ride is desired. Two-stroke engines deliver 1 power stroke for every 1 revolution of the crankshaft. This means they produce power almost constantly, giving them a very high power-to-weight ratio and quick acceleration, often described as punchy. Efficiency and fuel consumption. Four-stroke engines are generally more fuel efficient. Because their intake and exhaust cycles are separate, there's less fuel waste. They also have a dedicated lubrication system, meaning they burn pure fuel. Two-stroke engines can be less fuel efficient. During the scavenging process, some of the unburnt fuel-air mixture can escape through the exhaust port, leading to higher emissions and fuel consumption. Also, since they mix oil with the fuel, they inherently burn a small amount of oil, contributing to emissions. Design complexity and maintenance. Four-stroke engines have more complex designs with valves, camshafts, and a separate oil system. This complexity means more moving parts, which can lead to more potential points of failure, but also offers precise control over engine timing. They require regular oil changes. Two-stroke engines are mechanically simpler, with fewer moving parts due to the absence of valves. This makes them lighter, cheaper to manufacture, and easier to repair in some aspects. However, the lack of a dedicated oil system means they require a fuel-oil mixture, and their simpler design often leads to greater wear on internal components over time. Four-stroke engines use a dedicated oil sump and pump system to lubricate all moving parts, which is separate from the fuel. Two-stroke engines rely on oil mixed with the fuel to lubricate the internal components as the fuel-oil mixture passes through the crankcase. This means they are constantly burning small amounts of oil. Lifespan and durability. Four-stroke engines, with their dedicated lubrication and separate cycles, they generally have a longer lifespan and are built for sustained, heavy use. Two-stroke engines tend to have a shorter lifespan due to the constant burning of lubricating oil and the harsher operating conditions from the more frequent power strokes and less precise lubrication. In essence, four strokes are the workhorses of efficiency and longevity, while two strokes are the sprinters, prized for their power, simplicity, and lightweight design. Four-stroke engines dominate the automotive industry, powering most cars, trucks, and SUVs, where fuel economy, emissions control, and a smooth, quiet ride are paramount. You'll also find them in most motorcycles, generators, and a wide array of industrial and agricultural equipment. Their efficiency and durability make them suitable for long periods of continuous operation. Two-stroke engines, on the other hand, shine in applications where high power-to-weight ratio, simplicity, and quick acceleration are more important than fuel efficiency or low emissions. Think about those exhilarating dirt bikes, the precise power of a chainsaw, the thrust of an outboard motor on a small boat, or the compact design of a leaf blower. Their ability to operate at any angle without oil starvation is also a significant advantage for handheld tools. Conclusion: both four-stroke and two-stroke engines are engineering marvels, each perfectly adapted to specific roles. The four-stroke offers refinement, efficiency, and longevity, while the two-stroke provides raw power, simplicity, and a lightweight package. Understanding their fundamental differences not only deepens your appreciation for mechanical engineering, but also helps you understand why a particular engine type is chosen for a particular machine. We hope this explanation has clarified the fascinating world of internal combustion engines. Thanks for watching.